Thank you, Edgar, for such pretty much epic introduction. It is partially true because what I've been doing for the last, sorry, it's echo. What I've been doing for last many years was actually AWS, Terraform, and fanatism. So yeah, what it means is that I've been organizing and speaking and learning and teaching a bunch of different things in regards to these technologies. I'm really passionate about, and for the last 2 weeks, I can call myself as a certified Terraform fanatic, because HashiCorp has actually released certification. For those who don't know, or if you want to get raised in your company, you can go to hashicorp.com/certification, apply for certification, and you can get a raise. Isn't it cool? Right? I mean, that's why we need certification. Yeah, fanatic certification you can get in some countries, somewhere in the Middle East. What I also like to do is that I like to organize different conferences and different user groups. So I live in Norway. I'm originally from Ukraine, and I travel a lot, and I like to engage with the community. So if you will have any questions, or if you think that something what I said is not obvious or is totally wrong, or you think you know something else, what you can add, please find me after, and I will be really glad to talk to you. Usually what I learn from different events like this one, or from talking with my customers, I open source. And I open source approximately 90% of projects which I work with. It can be Terraform AWS modules, which are used by many thousand people, or it can be different tools related to Terraform, or it can be some learning materials in forms of reference architecture, or terraformbestpractices.com, which you can find some interesting information. Also, you can always follow me on Twitter and GitHub, or even LinkedIn if you're not a recruiter. So you're welcome to connect. And I usually tweet and share information just about these technologies. So there will be no things about politics, about different crap, which I really don't care about, but it's just about technologies and something what I think is really interesting. Okay, so what else do I do? As I said, I do a lot of things related to Terraform and all kind of DevOps consulting, or organized workshop, like the one which I had yesterday here. And I also like to bring different trainings to different companies, because I don't want them to stuck in the 19th century, and I want them to be progressing and using technologies in much more effective ways. I also like mentorship, which is usually doing code reviews once in a while and telling what is good, what is bad, where you can improve, and so on. I wrote an interview article a couple of months back where I actually describe how did I do this for the last several years. My email is publicly available. Please don't hesitate to send me anything. And when I say anything, usually people take it really literally. Without saying hi, they send me a Terraform snippet. Without any hi, without anything, hey, this is my code snippet, what's wrong with it? It's so funny. I usually reply with some Terraform error without even asking what's going on. So it's like CLI debugging using email. Sometimes I can also comment on Twitter as well. So if you paste some Terraform code in Twitter, you may get a response also with some Terraform feedback back. So it's like you can use me as Terraform CLI as well. Yeah, it's working pretty cool. And I also play chess. So if you know my name, which is Anton Babenko, you can find me on chess and you can ask Terraform questions there as well. Yes, this happens as well. So people know my name, and they sometimes try to find me anywhere and ask questions. This includes all Slack channels, all different other means. It's pretty fun. And I also like to solve challenges which I have never solved before. So I usually like to answer questions which you have at your work, but I honestly have never solved before. And I like to apply common sense and explain how I'm thinking. Maybe you will learn something from that. So one of a project which is actually used by many people. When I say many people, it's about several thousands of end customers who use it. to spin up different network infrastructure on AWS. It can be VPC, auto-scaling groups, security groups, and one of the most active is Elastic Kubernetes Service. So people just need to use existing code, and they don't have to know internal implementation in order to use it. That's the beauty of Terraform AWS modules. All of these modules are very high quality, which means that they're actually working out of the box. They all follow the same principles. They all have documentation, examples, and all these kind of things are applicable. I will talk about this in more details, but I can just say that if you are using Terraform on AWS, most likely you will end up using this code. And thanks for community, and I know some people in this room are using this already, so thank you very much for using those and actually opening issues. And opening issues is extremely important to me because I have no clue how you guys can use it. So when you open issue, it means that, oh my God, somebody is using and found bug. Excellent. I wish you fix it, actually. So another project where I'm involved is called CloudCraft. CloudCraft is opinionated and the best way to visualize your AWS infrastructure. So you have already created some AWS resources. You can go to browser cloudcraft.co. You can connect different components together. You can specify properties of each of these blocks, instance size or different type or IP address, whatever you want to specify. And then you can share this as a blueprint, or you can export this as an image, or you can embed it to different sources. That's everything possible, right? And at this conference, we're going to focus on DevOps, right? Because the company, event name is DevOps Unicorns, and I'm really glad to share some of experience which I got from before with you here. So infrastructure as code makes DevOps possible, and the main reason why I'm thinking this is a key definition, like what is actually it means, why it is so important, is that we always need to be able to reproduce what we make, and we have to understand why we made it, when we made it, what kind of changes we made, because we are not gonna to be evangelizing UI clicking in console anymore. Let's just forget about this. I mean, yes, we can go to different console and see UI and can understand it, but at the end of the day, it has to be written as something reproducible. I don't know what about you, but I'm not a big fan of automating using Selenium, even if it is possible to automate AWS console clicking using Selenium. If you are this kind of person, I have some project for you which will help you. It is called the AWS Console Recorder. So yes, you click on console and everything is end up as Terraform code. It's pretty crazy, but a lot of people like it because they already know console. Okay, so today we're talking about tool Terraform, which was designed for being able to just build, create, update, and destroy infrastructure safely and in predictable way, so that we always know what's going to happen before we actually execute it. When I say infrastructure, it actually refers to everything, like server, storage, network, and everything, okay? Or I like it actually, everything what is required to run an application. This is how typical Terraform configuration file looks like. So we are talking about Terraform 0.12 today because it is available. Some of my slides are actually outdated, and unfortunately I lost access to a tool which I can use to update. So they will be still in 0.11, but bear with me, it's still the same Terraform. So after we create Terraform files, we run Terraform init, we download some dependencies, then we see what kind of plugins or what kind of providers download. Then we run Terraform apply, which is another, like the most important command which we run in console. We see what exactly Terraform is going to change, and then we say that, oh yeah, that makes sense because that's what I want. So we type yes. Once we type yes, then Terraform is contacting provider and actually creating resources which we wanted. So at the end, we can see that my bucket bore has been created. Excellent, that's what I wanted. But how did we actually end it up with Terraform? Let's look a little bit to what we have with other providers. If we're talking about AWS, you may know that AWS has AWS CloudFormation, or if you've been following AWS for at least the recent year, you may have heard about Cloud Development Kit CDK. These two tools are designed to work with just AWS resources, and it's pretty hard to implement it to support other type of resources, even if you want. So Google Cloud is also a solution by Google to manage primarily Google resources, which you can use Jinja, templates, and Python. So yes, you can use that one as well. In Azure, you have Azure Resource Manager if you're a big fan of JSON, or if you want to not understand what's going on, this is a tool for you. If you've been using configuration management tools before, like Chef, Puppet, Ansible, you can achieve pretty much similar using those. So yes, you can describe what kind of resources you want, and then these tools will perform similar actions. But as you can see that all of these tools are specified or managing resources in limited scope. So here is Terraform, which started in 2014 with an idea that, hey, we don't want to have N+1 tool to manage all these things. We want to have fewer tools where the common ground is the same. So we have to use something what doesn't exist. So Terraform supports all these providers plus more than 250 publicly available providers. So if you are using CloudFormation, you may think like, oh yeah, CloudFormation is cool because I'm never going to jump to anything else. That's maybe true. So you will actually live with AWS for quite some time. That's great. And if you think about what kind of features Terraform has while, let's say, CloudFormation doesn't have or any other doesn't have, Terraform has a concept of teamwork built in. So there are features built in Terraform which allow you to share your code, to distribute it somehow, to version your modules, and be able to see what's going to happen. If you look into 2014, one of the sales points back then was that Terraform could actually tell you what is about to happen. So you don't have to run blind and say like, hey, this is my code, I have no clue if it will work, but let's run it in production. Honestly, that was the only way how you could do this back then. There were no change set, no drift detection in CloudFormation. So you always have to fingers crossed and let's upload this file and then fix all issues in production. There were no better ways than that. Now there are some easy ways, but still there is no concept of teamwork built in. And Terraform was built from the ground up to support just modern systems. So there are no legacy behind it. It's working just for what we have for the last few years. It's not possible to manage, let's say, wireframes right now. You can do this, I can show you how, but it's not designed for that, okay? If you have wireframes and you want to use Terraform, it can be a good provider. So you can write provider if you are good in Go, and actually first you have to make an API for your wireframe and then write provider, which is pretty good. So if you look into what is possible to manage using Terraform, think about this is that when you have any dependency between any resources, like in Google G Suite, you have user ID and you have his or her files, or you have Dropbox files which belongs to folders, or you have some other dependencies between different entities. Or if you look into Minecraft, you may think, why Minecraft, right? So Minecraft, imagine a situation where in Minecraft you have sheep, okay, this small sheep, and you have floor. So if you drop sheep and you don't have floor, the sheep will fall and will be dead, right? You don't want to kill sheep. So what you have to describe in Terraform using Terraform Minecraft provider is that you have to specify that sheep is actually dependent on floor. So then when you use Terraform provider to build your Minecraft scene, you will have to specify that first there is floor and then there is sheep. So when you drop sheep, it first build floor, so you don't lose your sheep. And yes, it is possible to manage entire world in Minecraft using Terraform providers, using the same syntax, same features of Terraform. You can use loops, you can use conditions, you can use whatever you want. You can build the whole scene in Minecraft using Terraform. You can even order Domino Pizza if you don't mind to put your credit card details in plain text, including your CVS code. So yeah, infinite opportunities. So as soon as there is an API, yes, it can be managed using Terraform. And if you look into what was actually the most awaited features and what people were asking for quite a long time, it actually ended up as Terraform 0.12, which was released in May, which was announced a long time ago, and people were anticipated this release for a very long time, and they were thinking like, hey, 0.12 should be out, I want to use it immediately, I want to be able to have all my code fixed for me, and Terraform is not a good product because it's not starting with 1, it's 0.12, so it's not production ready. No, it's not true. Terraform is production ready. We managed to survive for quite a long time without any of these features. We used to do a lot of hacks. Some of these hacks are now not needed anymore, but Terraform 0.12 is there, and I will talk about this, why you should not be so much excited about it, okay? So if you're still excited and you think that Terraform 0.12 is thing which will fix all of my code and now everything will be good, I have some bad news for you. But they will be at the end, so you will have to sit here and wait till the very end. Okay, now let's start with something good, something easy, something small. Let's manage AWS network stack. So we have need to create VPC. So we create this code snippet, we specify a pseudo block, we say that, hey, Terraform, go and make this VPC. That's pretty obvious. We all wanted to have VPC because we want to deploy something there, we want those resources. And we also want to have access to the internet, so we add internet gateway because we need to go offline or online. And we also need to have a couple subnets, so we need public subnet, maybe private subnet, and so on. So we start adding different resources into this file. Then we realize that we need to have NAT gateways, a lot of routes, maybe route tables, and many, many other things which you can imagine. So quite soon we will realize that our code is actually not small. It's not like 5 lines, 10 lines. It's actually 300 lines of code. It can be 10, 20 kilobytes of code easily, because we are just adding all these things together. And I'm sure that you have at your work, if you are using Terraform, you have been to this position where you just plug in and add new resources, and your files are growing, growing, growing. And then you obviously will start to think that, oh my God, code is increasing, dependencies become unmaintainable. If you run Terraform plan, something is taking 3 minutes, now it's taking 5 minutes. Terraform is bad, that's because it's not starting from 1.0, that's because it's not ready for production. And you think that something is going bad. Then you go to documentation and you discover that, oh wow, there are Terraform modules, which is actually just a collection of Terraform configuration files in one folder. So you will understand that's what I need, because in other languages we have classes, we have packages, and so on. So yeah, that's what I need to use. Cool. Then you will figure out that, oh my God, there are actually a lot of modules out there, and there are resource modules, infrastructure modules. So let's look into 2 different types. It's important to understand that there are at least these 2 different types. And if you think about them this way, it will make your life and code reuse much easier. So resource modules are usually very flexible in configuration. They don't contain any logic. They just create resource in any configuration as you specified. So since they don't contain any logic which is limited to your company, they're great examples of being open source and shared everywhere. Invocation of these modules looks like this, that we specify source where we want this module to get. Like in this example, we are getting to Terraform Registry, and we download this module of specific version, and we pass several arguments to it. So that's typical how this invocation looks like. And then you may think like, yeah, but security group, why do I need to do this? I mean, security group in Terraform is just 2 resources. It's security group and security group rule. What can be the use case for that? Why I even need to create security group module, or why I have to use it if this is just 2 resources? So would you use Terraform module to manage AWS EC2 security group? I'm asking you. Can you raise your hand and say that, oh, that's a bad idea, I would never do this because it's so easy, I will just write 2 resources and life is better outside of computer? go away. So I guess that you think that this is a bad idea, and let me show you some cartoon. So what you see here is actually internal implementation of very powerful Terraform AWS module, which creates security group in all configurations. There are about 600 lines of code which creates security group with different properties, because it's probably not your main business that you don't know what kind of arguments can be specified together. For example, you cannot specify IPv6 and IPv4 and the same rule. You cannot specify prefix list together with self-reference. You may think that you can specify several overlapping rules. All of these things are limited by API, or by AWS, or by Terraform AWS provider. And historically, security group resource was one of the most complex. So that's why if you are using this just as a resource, you will have to know about all of these internal implementations. And what you can do by using this module is that you can just hide all of this complexity and specify values which you want. So you say, I need security group with these rules open. That's it. You don't need to go in internal implementation and know how it's done, why it's done, what's the limit, and so on. So there are a huge benefit of hiding this complexity and using existing Terraform modules, even for things like security group or creating S3 bucket, which is usually people think like this is the most easiest resource. I can just create S3 buckets. Yes, you can, but you cannot change it. So there are solutions to Terraform which allows you to actually apply changes. If you do just resource, it will make it pretty much impossible. If you are not sure that you follow what I'm talking about, I recommend you to check S3 bucket module for exact implementation. I think it's the most complicated one. I didn't even bother to put it on slides. Another type of module which you have to understand, and this is where I want you to focus most of your time if you're working with Terraform, is actually creating curated modules. Curated or company-wide modules is something where you know how your company is going to be built something. So this is where you enforce different strategies like encryption, naming, tagging, and so on. So this is where you spend time on actually putting all of this logic, maybe connect different components together. So the end result of infrastructure module can be the way how you solve typical architectural problem, architectural pattern. For example, infrastructure module can be the module which creates an application, let's say, and put it into S3 bucket. So there are about 10 different resources involved, including different bucket policies. All of these things can be created conditionally, and you actually spend a lot of time thinking about how you deploy application into the bucket inside of your company. So you need to use resource modules to do that. So infrastructure module invocation looks very similar. You also specify source for it, like in this case, from the registry, and you specify several arguments to it. Inside of this module, you are calling several resource modules similar way as you did with just resource. So this is the way how you work with, this is like the main separation between these two groups of them. Now let's look into different good things and bad things. So before you start writing any code, I encourage you to check 1,500 of Terraform modules published by the community on the registry. I'm still very much surprised when I speak at conferences and when I ask people, raise your hand if you don't know about existing of registry. And believe me or not, but even after 2 years of announcement, there are a lot of people who don't know about existing of registry. You don't have to raise your hand now because it's a shame, but just believe me that there are a lot of information out there which you can use, and it will have to be used if you want to not repeat yourself and if you want to piggyback on other people's code. This includes Terraform AWS modules, which are published there. So another thing which people ask quite often is that, okay, I'm using my infrastructure module repository, and I think something is not right, because now Terraform plan is taking a long time, and maybe I have to do something else. Because if you specify inside of your code many module blocks, and you point to the same repository, when you run Terraform init, it will actually download all of this repository every time. So your Terraform plan, or Terraform init, sorry, will take time. And there are ways to avoid it. The first way is make something like git clone of all of this and put it in in the same file system next to the code, so that you can use relative paths. Or another way, which is I didn't even have time to update, because I learned about this like good release which came a couple hours ago, I think, project called xterrafile. If you get used to requirements.txt, package.json, and other gem file or whatever else you are familiar with, you may want to have the same stuff for Terraform modules, where you describe or declare all of your modules with version requirements, and you run xterrafile install, similar as npm install. It will download half of internet to your computer, and then you use local path. So this is a new project. It has just 20 stars, so you probably have to go and click star at least to tell the guy in Manchester that it's good. Or another project which is called MBT, which you can use to build versioned artifacts and put them into your Artifactory. You can check this out, and I'm sure it will be a very effective way if you already have a pipeline where you build some packages and then you treat your infrastructure modules the same way. Let's look into what is actually a very frequent problem. Okay, there are few things which people use. If you want to publish your module and you want other people to use it, just never include provider block into that one. If you specify provider block, it's not possible to override. So if other people want to use it and you specified it explicitly, it's not possible for them to use your module. This is partially explaining why a lot of modules has a lot of forks. So the main thing which people do there is that they remove provider block and use it themselves. So just remove it, and it will be already better than many other. The reason why people want to use that block there is that they want to specify provider's requirement version. But to do that, you can use a Terraform block where you have to specify the required version of Terraform as well as the required providers. This is pretty unknown feature for many people, that you can actually have Terraform block and it contains configuration for Terraform, for providers, and so on. So I encourage you to use this way if you are thinking about reusability. Second evil part in Terraform modules is called provisioners. So simply don't use them, because you are connecting to different type of resources incorrectly. So in this case, you are creating VPC and then you are calling local exec provider because your VPC resource does not have enough features. For example, you are using some features of VPC which is not supported in Terraform, but you know that AWS CLI supported. So this was natural way, and you think that provisioners exist for these reasons, so you can use it. Yes, you can use it, but then another guy comes and he's using Windows, so unfortunately he cannot use this one. So again, if we are talking about reusability or anything what is going to be executed outside of your known comfort zone, which is your computer, your project, your AWS account, just avoid provisioners in all resources. This also includes running provisioners on AWS instance. I believe that this is wrong way to do, because you're actually doing pretty similar things. You think that, oh yes, I'm creating an instance, and then I'm calling provisioner to deploy my application, so I'm calling Ansible playbook. Yeah, that's right, but you're doing this from your machine, which is not exactly the trigger point. The trigger point here should be using your cloud provider capabilities, which in AWS is user data or any form of cloud init scripts. So in user data, you can put script, for example, to download from S3 bucket and then run Ansible playbook locally on this machine. It will be faster and it will be actually scalable. Because from solution 1 to solution 2, you can easily migrate if you are going to make this instance highly available and you are going to put it in auto-scaling group with minimum, maximum desired 1. While if you would use provisioners, you cannot put them into launch configuration. This is important to understand. So if you still think that, yes, I want to extend capabilities of VPC resource, for example, I want to use AWS CLI to do something what is not available in the provider. You can use special type of resource which is called Null Resource. And this is actually the right way to do if you need to execute some shell scripts or something in addition or after some resources are created. There are a few things which I believe are actually important, and I put them into this order, saying that as soon as you have good documentation and you can prove by examples how your code works, it's really good. But if you have also implemented a lot of features and your code is clean and you don't have hard-coded strange values, it's great. But I put tests on the very bottom level because I really don't understand in which exactly cases you want this specific module to work. So if you provide your specific known use case into test, you are testing just happy pass, and this is not covering majority of cases. For example, one use case for Terraform module can be that you test it in your AWS account where you have high limits, where this service is available in the region where this feature exists. And then you say, hey, my module is working great, you can use it. And then this person run it in region, for example, EU Central 1 Frankfurt is totally different from EU West 1 Ireland. I test always in Ireland, and then guys from Frankfurt said that, oh yeah, but we don't have even this feature in output from API from AWS. How could I know that? I'm not speaking about closed regions like US, Gulf, or Mumbai, or Hong Kong. They are totally different as well. So what exactly I'm testing? That's a big debate, and if you want to discuss it, we probably will have time during open spaces today, if there will be such concept. So let's talk about this later. So what about Terraform modules? And you think that, oh yeah, that's enough. We have them, great, go home, we'll use them, that's all, right? Who thinks so? Should I go home? No, okay, thanks. So no, because Terraform module is just beginning. So we start putting things into module because we feel need for that. Now we have a lot of modules, right? Some infrastructure module, resource modules. So we are thinking like, oh my God, it's going to be another type of mess. It's like high-level mess. And you think about how to structure your Terraform configurations, and you think like, okay, how to actually call them, because I want to call them maybe in some order, maybe with some dependencies. Maybe they have to be called only if something changed. So this is what I usually call as orchestration. I don't know if it's a good word or not, but I like it, honestly. And there are two types of grouping, the way we can think about this. Many people start with all-in-one, where you have few TF files where you invoke a lot of modules, like VPC, application load balancer, and you just invoke them one by one, pass arguments between modules. So quite naturally, you will soon discover that Terraform plan takes 5 minutes, and you don't like it. You start to play with different dash target, make files, and so on. So then on the other side of this spectrum, there is one-in-one, where you have actually much smaller blast radius, and all folders are very limited. So folder is usually invoking 1, or maybe 2, maybe 3 infrastructure modules, and that's enough. So which way do you think is good? All-in-one, one-in-one? Who think that all-in-one is a great way and you have to use it or you use it? Don't be shy. Really, don't be shy. Yeah, oh, Edgar's is using, that's excellent. Yeah, can you raise your hand if you like let's say, all-in-one and you think it's good. I think one guy said that it's not so bad. Yeah, so few people say that it's not so bad. What about one-on-one who think that this is a great way, you have to use it, you are using it? So can you raise hand? I mean, you're so shy, guys. Is it everything like this in Riga? No, actually a few people. So yeah, similar amount of people. Okay, so I can tell you the MFA is actually somewhere in between. It's somewhere in between because you never know what exactly, there is no like universal solution. Otherwise we wouldn't have job, honestly, if there would be just one solution. There are as many solutions as people in this room. So every time when we are starting something new, we have no clue about relations, about how different modules output will feed to another one. So we usually start with just one file and we connect them together, we experiment, we try different things. Once we figure out that, okay, this is let's say a project where we're going to use different network components, so there will be VPC, there will be application load balancer, there will be hundreds of microservices, so you already know some structure. So one-on-one in this case is actually more efficient than anything else. So think about this is that when you are using one-on-one structure, you can actually share your code between different projects because it's just a plugin. It's like invoking another module. You don't have to copy paste a lot of stuff. You don't have to think about sequence of execution. So you can share code much easier. And if you know what is Terra Grant, you can use Terra Grant with one-on-one much more effectively. I will say about what is Terra Grant in a bit later. So what kind of orchestration methods can you use? So if you have all-in-one, then you put a lot of files, a lot of modules, resources, everything is taken slow, and you are going to try different solutions like specifying target. So you can say -target module.vpc because you want to update just these resources. Or you can script some makefile or some Python script, whatever. So you can do your own, you can actually do something what Terraform is supposed to be doing, but it's doing it slow. So you are writing some scripts, you are defining some sequence, for example, run Terraform apply in this folder, then change directory to another folder, and run Terraform apply there, and so on. So you are actually doing a lot of heavy lifting yourself. But what if I tell you that Null Resource is a good way to execute local exec? What about this way? That you can use Terraform to call Terraform. How do you like this way? Does anyone like this way or think this is good or bad? Of course, do not try this at home. So yes, it is bad way because this is not the way how Terraform was designed, and Terraform can be used to run Terraform from Terraform. There are a lot of inceptions fun which you can do, but this is definitely not Terraform best practice talk. So if you think that you need to overuse Terraform and make your life harder, use this one. Okay, if you want to do things properly and more predictable and limit scope of what you're going to do and actually have all your configurations look exactly like this. So this is file structure which creates network resources and launch EC2 instance inside of EU West region. That's all. There are no Terraform configurations inside of this. So this is where Terra Grant is beneficial. Terra Grant is a tool which allows us to orchestrate invocation of infrastructure modules. So the main thing inside of Terra Grant is your infrastructure module. So you have module which does something. This module accepts some arguments like name, AMI, and instance type. And this module has some dependencies. For example, you can launch EC2 instance only after network stack has been created. So this is exact configuration using Terra Grant, and if you want to have code reuse to the extreme level, Terra Grant so far is the best option out there. What about Terraform workspaces? Like, let's talk about this one. I know a lot of people like it. So Terraform workspaces allow the use of multiple states with a single configuration directory. Does it sound cool? Think about this. You have one folder of Terraform configurations file, you run some command, and you create these resources. And then you run another command, and rerun the first command, and you have another type of files. So it's passed to mess, okay? It's passed to something what you cannot control. And the main reason for that is that Terraform workspaces, in my opinion, they were designed from totally wrong angle. So they came not from what user want to do, but they came from business. Business say, hey, we need this. Okay, what can we do? Oh, we have workspace. If I am, as a user, want to look into the code base, and I cannot answer, for example, hey, what kind of workspaces do we have? Do we have workspaces in 5 environments? Like, do we have 5 workspaces, or do we have just one workspace? When these workspaces were deployed, what is the difference between workspace 1 and workspace 2, because they can be deployed in different time? All of this and many other tricky questions you cannot answer if you're using workspaces. So my recommendation for that is just don't use it. Okay, the solution is, again, use reusable Terraform modules instead of workspaces. Yes, you will have a little bit more code to maintain, but at least this code will be easy to understand, and you will actually think about this as, if I have this code, then I have this infrastructure. You don't have to run Terraform in your head in order to be able to answer, like, what is the difference between this? Oh yeah, but he sent that he ran this code. If code present in specific place, then yes, there is this environment created. Think about this as grouping by directories. So I have one summary here, which is not actually a summary, which is because there is still one point left about Terraform 0.12, but I just want to highlight that Terraform modules are absolutely must-have. So yes, you write resources, but you group them by modules. And once you group them by modules, you actually have to use some orchestrator like Terra Grant, and skip different things like Terraform workspaces, and make your code as easy to understand for humans as possible. Don't try to save 2 kilobytes here, 2 kilobytes here, optimize something, encrypt into one file, but make a lot of conditions there. You are making infrastructure as code should be treated as code for humans, not for machines, because machines doesn't care about your code at all. And now let's talk about Terraform 0.12. I have something like 3 minutes and about 9 slides. So Terraform 0.12, what actually does it mean? As I said at the very beginning, a lot of people were anticipating that Terraform 0.12 is almost there, and I can just wait a little bit and start using, and then I will have loops. I will have a lot of conditions. I will have all features created by HashiCorp and by Terraform community, which I can use. So I can write much more powerful code. But that's fine. But then I look into another angle. Who are we talking to? Like, even in this room, I'm sure that there are people who are kind of thinking that, okay, people are talking about Kubernetes, people are talking about Terraform, and I want to know what is Terraform. But I have no clue about AWS. I have no clue about DevOps. I'm not interested in that, because I'm just user. Or another type of people who are usually DevOps engineers, they think like, oh yeah, that's cool. I want to do more hands-on, more of these cool features, and I know AWS and I can connect different things. I'm a fan of that one. So think about this as 2 different types of people, okay? Maybe you belong to 2 of these types of groups at the same time. That's fine, that's great, actually. Then you can benefit from both. But if you are thinking about these 2 groups of people, Terraform developers' responsibility is actually to implement company standards. And they have to know how to use Terraform, how to write modules, how to update them, what is the life cycle of them, what is AWS and or other providers, it doesn't matter. And they have to maintain reference architecture which is spread across the company. They are actually hands-on in everything what I said earlier. So they should be responsible for writing these modules, making them effective, and doing all these tricky bits which are internal. On another side, there is Terraform user groups who are always domain experts, and they just know they don't really care about how you wrote these modules. All they want to do is they want to just get this module, figure out what kind of key values they have to fill in, and that's it. They don't care about that inside of it you used some logic and even you forgot about what you did. So all they want to do is that they want to apply their domain expertise and get their job done. They may not have even LinkedIn profile with Terraform, which is pretty cool. So we probably can hire more people like this. In many organizations, you already have dedicated people who know Java, business logic, front end, whatever. We don't have to tell them, hey, by the way, now go and learn Terraform and Anton is giving workshops. No, you don't have to do this. It's okay, but you don't have to do this. So think about them as being focused on just that one and nothing else. So Terraform 0.12 for developers, yes, it allows us to do everything, all these cool features. But users, they shouldn't be really more excited than, okay, fine, I just need to know which module I am talking to, what key values you are expecting me to fill in. That's it. That's end of story. We don't have to treat Terraform as an easy tool which everybody can use. If we do this, then we will see what has happened to other tools like Ansible, where we say, hey, it's easy to get started, and what we have now is lots of crap. Like, if you look into any projects, you will see a pile of crap, right? And with Terraform, it's similar. A lot of people just treat it as just another tool, and it's expanding, 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 and then bad quality is ended. So I promised the final summary. The final summary is that Terraform 0.12 is absolutely awesome. But it's awesome 90% for people who use Terraform, who write in modules, know internal implementation. And just 10% of benefits go to people who actually use Terraform modules created by DevOps engineers. So think about this separation and try to use Terraform in really easy way. If you do something what you think is bad, then most likely it is bad. And Terraform is not going to fix even when 0.13 will be out or 1.0 will be out. It will not go to your code and tell you, hey, this is bad code, go and fix it. There are different projects which can give you some suggestions, or contractors who can say like, hey, I can rewrite all of this. So thanks for that, and remember to rate my talk on WhatsApp or WorksUp. Yeah, WhatsApp. WhatsApp is also good. So thanks a lot.